We're asked to sketch a graph of this function with my mouse there, along with the parent function. And I'm going to assume what they mean by the parent function. Let's call it g of x. It's not going to work. Okay. So g of x, I think they want log base 5 of x to be the parent function. Let me check. Maybe they want log of x without like a common log. No, parent function is what I got there. Yeah, okay. So that's what they want for the parent function. Okay, so to make that graph happen, let's start with the parent function. It's log base 5 of x. Let's make an x and a y table. We can plug in some numbers for x. And you might not know what numbers that are good to plug in. You know, there's some we can plug in that'll give us some weird decimals. But look, this is base of 5. What that means is that you're saying, hey, what power do I raise 5 to be to make it equal the number I plug in for x? Let's try x equals 1, because the question is, what power do I raise 5 to be to make it equal to 1? And we have a special power that makes any number turn to 1. It's 0. Okay? 5 to the 0 power equals 1. So if I plug in 1 in for x, I get out 0 for my y value over here. Okay, let's try out another one. We want powers of 5, so let's plug in 5 in for x. Because that's what a logarithm does. It says, what power do you raise that base to be to make it equal the argument, the number inside the parentheses? 5 to the first would equal 5. So 1 is our answer there. And another power of 5, how about log base 5 of 25? Because 5 to the 5th power would make 25. So if I plug in 25 in for x, I should get out 2, because 5 squared would make 25. And so if we graph that real quickly, 1 on the x, 0 on the y, 5 on the x, 1 on the y, and then the next one would be 25, so way down here, and then 2 on the y, so it grows pretty slowly. And so this is the sketch of the graph. Notice that I didn't touch the y-axis, because look, if you plug in 0, the question is, what power do you raise 5 to be to make it equal to 0? So I can try that with my calculator. Look, 5 to the 0 power, that makes 1. We're trying to raise 5 to some power to make it equal to 0. Oops, I wrote 0 there. That's not correct. And we're trying to find out what power am I going to plug in so that 5 to that power would make 0. I'm trying to get out 0. So 5, let's try to the 0.01 power. That doesn't help. 5 to the maybe -1 power. 5 to the -1 power, that makes 0.2. Getting closer to 0. Let's try 5 to the -10,000 power. Closer, but still not 0. You never actually reach x equals 0. Okay, so that's why there's a vertical asymptote at x equals 0 for my parent function. It'll be the same asymptote for the function we're graphing. So we got the parent function graph. Let's do the same thing for f of x. Let's make an x and a y table. And it's a base of 5, so we're thinking of powers of 5 to plug in. If we plug in x equals 1, then we got 1/4 times log, I don't need that there, times log base 5 of 1. And remember what we said about this. What power do you raise 5 to make it equal to 1? Well, anything to the 0 power is 1. It's 0 here. This result in a calculator. You could just Google search a logarithm different base calculator, and you can plug in 5 for a base. You see it gives you 0. Okay. Let's try out another power of 5. So if I plug in 5, I got log base 5 of 5. So what power do you raise 5 to be to make it equal to 5? You raise it to the power of 1, right? Keep it where it is. So the result here is 1/4. If I plugged in 5 in for x, I got out 1/4 for y. And one more, if I plug in 25 over here, I got 1/4 log base 5 of 25. We said that this result is 2, right? When we plugged it in over here into our parent function. 2 times 1/4 is 1/2. So the blue function has some dots that are growing very slowly. We got a dot at 1, 0, same as the parent function. At 5, we're a fourth of the parent function's value. And at 25, we're at 1/2 because, again, that's a fourth of the parent function's value. Probably a little lower. So you should see this really similar sketch, except the blue function should be a little bit lower than the red function. Domain, all the possible x values. You can't have 0 like we discussed, right? You can't plug in 0 into these functions and get out a y value. So I'm using a parentheses to say everything up to but not including 0. That's the smallest x value I can have. The largest x value, I can keep going, right? I can plug in whatever the heck I want. I can plug in 1 billion in for x. The range of the y values. The lowest y value I can get, I go towards -infinity. I never reach a lowest value. Keep going. And this might seem a little counterintuitive because it looks like it levels off, but this does keep increasing. In theory, you could plug in 1 billion in for y, use your calculator, and get a value for x. Okay, that's the range. And the asymptote we said is x equals 0, because x equals 0 is this vertical line. It's the y-axis. You never touch it. You get infinitely close, but you never touch it.